We're going to look at trends in the periodic table in two separate sections here. The first one focusing primarily on size. We've got these concepts here. If we can understand how an atomic shells, how that affects the size. We've gotten then these two terms here, shielding and effective nuclear charge. Once we can use those to explain size, we can then use the size of an atom to explain all these other properties. So size is incredibly important. So let's take a look. The first thing we're going to look at for size is how the number of shells affect the atom, and it's really, really simple. They're like layers. Atoms have layers. Ogres have layers. The more layers you get, the bigger the atom is. So real simple. How many shells does it have? That is the predominant factor for how big of an atom is. If you can get different number of shells, you know which one's bigger. So compare the size of these atoms, smallest to largest. Sodium, lithium, and potassium. Okay, so how many shells does each one of these atoms have? Well, sodium has 3 shells. Lithium has 2, and potassium has 4. And we know that because it's a valence shell. Sodium's electrons are 3s1, lithium's are 2s1, and potassium's are 4s1. So the smallest one, lithium, sodium, potassium. But once atoms have the same number of shells, we need to look at another property. So we look at this idea of shielding to get our next term. There's a positive charge in the nucleus. That positive charge is pulling all the electrons towards it. So there's an attraction there. But these other electrons in the middle are repelling those valence electrons. And we only really care about the valence electrons because that's where the size of the atom, that's the outside radius. So that there's a push and a pull, and the net effect, instead of saying there is a nuclear charge attracting the nucleus and the valence electrons, we say there's an effective nuclear charge because the core electrons repel. Effective nuclear charge. Really, it's simply enough just how many protons the atom has, whichever one has more protons in a row has a higher effective nuclear charge. But we don't want to say number of protons, and we don't want to say the nuclear charge because some of it is shielded. So that word shielding is really just where we get this word effective from, effective nuclear charge. So compare the sizes of these atoms, smallest to largest. So let's do our comparison again here. How many shells do they all have? Because if they're different, then we don't need to worry about the effective nuclear charge. Iron, cobalt, and nickel, well, unfortunately, they all have 4 shells. So now I need to look at something differently. Let's look at the number of protons, because that's what it's related to. Iron has 26, cobalt 27, nickel 28. Now that means that nickel has the most protons with the same number of shells. So nickel is going to be my smallest atom. Those protons pull it in tighter. But we don't say the protons, we say it has a higher effective nuclear charge because those valence electrons are not being pulled by 28 protons, just some of them. But still, more than cobalt and iron. So cobalt would be next, and iron would be the biggest of those. Okay, a little harder example. Compare the sizes of these, smallest to largest. So let's examine how many shells they all have. Bromine has 4. Chlorine has 3. Selenium has 4. And sulfur has 3. And then we look at protons to get the effective nuclear charge. Bromine 35, chlorine 17, selenium 34, and sulfur 16. Okay, so Remember, we count the protons, but we're still saying effective nuclear charge. We don't want to say protons. Now, when we look at the number of shells here, chlorine and sulfur are guaranteed to be smaller because they have less shells. So this is kind of the predominant property. Within those two, now I need to compare the effective nuclear charge. Chlorine has more protons, so it'll have a higher effective nuclear charge. Chlorine will be the smallest of those. And then sulfur will be next. Okay, so this is the smallest. Now I can go to bromine and selenium. They both have 4 shells, but bromine has more protons, so it has a higher effective nuclear charge. And then selenium should be the largest. So we have to be able to understand size to explain all of the other properties. By doing that, first we look at the number of shells an atom has, and then if the shells are the same, then we have to go another layer and compare how many protons they have to see which one has a higher effective nuclear charge, which means the valence electrons are pulled in tighter, which makes it smaller.